Hello, today we shall learn how to do some derivatives with parametric equations and how to construct tangent lines. Suppose we have a curve in parametric form, curve with equations x equals x of t, y equals y of t. Let's say the curve looks like that. And suppose we have a point on the curve with coordinates x0, y0, and we want to construct a tangent line, which will look like this. Here, x0 is the value of x at some t0, value of parameter t0, and y0 is y of t0. How to construct this tangent line, how to write the equation. Now let's remember how we write Cartesian equation to tangent line. The Cartesian equation at this point x0, y0 will look this way. Y minus y0 equals m, which is the slope, x minus x0. And the slope, when we work with the y function of x, the slope, this is y prime x0, the derivative at x0. Now how to find the slope if we have parametric equations? We reason this way. Y prime we can write like dy dx. And now we can manipulate this, divide top and bottom by dt, and this becomes dy dt over dx dt. So this will be shortly y prime t over x prime t. So this ratio of derivatives y prime over x prime, this represents the derivative dy dx. And if we want to find the slope at some point x0, y0, we just have to evaluate this for t0. When t equals t0, the slope m will be y prime t0 over x prime t0. So now we can write the equation of the tangent line. Written in Cartesian coordinates, this is y minus y0 equals mx minus x0, where m is this ratio. Completely with in terms of t, this will be y minus y t0, because this is y0, equals y prime t0 over x prime t0, which is the slope here, times x minus x t0, which is x0. I shall put this in green. The formula for tangent line at the point x0, y0, which corresponds to t0. I shall write this down here. Tangent line at the point x t0, y t0. Okay, now let's see some examples. Find tangent line for the curve with parametric equations x equals root of t, y equals t squared minus 2t, for the point, at the point corresponding to value of the parameter t0 equals 4. Okay, so first we had to find the point x t0, that's x of 4, that's root of 4, that's 2, that's x0. Y t0, this is y of 4, this is 16 minus 8, that's 8, it's y0, 8 here. Now the point is 2, 8. At this point we want tangent line. Now the derivative, x prime t is 1 over 2 root of t. You can write root of t 1/2 and use the power rule. So x prime 4, 1 over 2 root of 4 is 1/4. Y prime t is 2t minus 2. Y prime 4 will be 8 minus 2, 6. So the slope m will be y prime 4 divided by x prime 4 will be 6 divided by 1, 4 is 24. You multiply 6 by 4. And here comes the equation of the tangent line. Cartesian equation, y minus y0, which remember is 8, equals the slope 24, x minus x0, which is 2. This can be written y equals 8 plus 24x minus 48. So this will be y equals 24x minus 40. Slope-intercept equation. Good. Next example. Now the same for the curve with equations x equals e t times sine pi t, y equals e power 2t, and it's find the tangent line at the point corresponding to 0 equals 0. We have to do the same work. Find derivatives, slope. So here is, well, let's find first the point. The point x0, y0. So x of 0, well, this will be 0. Sine 0 is 0. Y of 0 is 1. So the point is 0, 1. We want tangent line at this point. Here x prime t, using product rule, et sine pi t plus et. Now differentiate the sign. We have pi comes out, cosine pi t, like that. And when we evaluate for 0, x prime 0, first term will be 0, and then we have 1 times pi cosine pi is negative 1. So this will be negative pi. After that, we find y prime t, 2 times exponential 2t, y prime 0, this will be just 2. And now we find the slope. M will be y prime 0 over x prime 0. So the slope is 2 over negative pi. It's negative 2 over pi. And the equation of a tangent line. y minus y0, which is 0, which is 1, equals the slope x minus x0, which is 0, so just x. We can write it y equals negative 2x over pi plus 1. This is our tangent line. Next, let's do this. A little bit modified problem. We have a curve with parametric equations x equals 1 plus root of t, y equals e to the power t squared. Find tangent line at the point 2e. Now the point is given, and we know the equation of tangent line. Let's write again y minus y0 equals slope x minus x0. So x0, y0 given. To find the slope, we had to work with t, differentiate, find ratio, but we need to know t0. We need to evaluate the ratio that there is at t0. So how to find it? We need to expect the curve. For what value of t, x will be 2 and y will be e. So we will need 1 plus root of t equals 2, using the first equation. So root of 2 has to be 1, so t has to be 1. Does this fit the second coordinate? Yes, when you take y of 1, this will be just e. So our t0 is 1. That's important. Now we find the slope. X prime t, 1 over 2 root of t, y prime t, remember how we differentiate the exponential function? This will be 2t exponential t squared. This is the rule. E power u prime is u prime e to the u. That's our rule. Chain rule. Now, x prime 1, evaluating for t0, this will be 1 half. Y prime 1, plugging 1, we get just 2e. The slope y prime 1 over x prime 1 will be 2e divided by 1 half. So this will be 4e. The equation of the tangent line. We know x0, y0. So tangent line will be y minus e equals this slope, 4e, x minus 2. X0 was 2. And this is it. We can multiply on the right side. Will be 4ex minus 8e. Then moving e to the right side, this will be 4ex minus 7e. Slope-intercept equation. Slope is 4e. Okay, very good. Another one of the same nature. Given is the parametric curve with equations x equals sine pi t, y equals t squared plus t. Find tangent at the point 0, 2. Again, we have to find t0 for which we get the point. So x t0 should be 0. Y t0 should be 2. So what is t0? Thinking more carefully, we discover that t0 has to be 1. Sine of pi will be 0, and y of 1 will be 1 plus 1, 2. Okay, now we proceed like before. X prime, this is pi cosine pi t. X prime 1. Cosine pi was negative 1, so this will be negative pi. Y prime is 2t minus plus 1. Y prime 1 will be what? 3. And the slope m will be y prime 1. X prime 1 will be 3 over negative pi, will be negative 3 over pi. And now we write the tangent line. The equation in Cartesian coordinates. Cartesian coordinates, that means rectangle coordinates. So y minus y0, y minus 2 equals this slope, x minus 0. So this will be y equals negative 3x over pi plus 2. Slope-intercept equation. Okay. Now, let's solve this problem. It's a strange problem. Given is parametric curve with equations x equals just a second. X equals t squared plus 1. Y equals t squared plus t. The question is, for what t the curve is concave up? Now what to do? We have from calculus, from Calc 1, we know that if we have a function y equals y of x, we have concave up when y second is positive. Now we have to see how to deal with the second derivative when we have parametric equations. Now the first derivative, dy dx, we wrote y prime t, x prime t. So let's find this in terms of t. X prime will be 2t, y prime will be 2t plus 1, and x prime is 2t. So this will be 1 plus 1 over 2t. This is the first derivative. The second derivative, this is the derivative of the first derivative, which we can write this way. dx y prime, so this will be d dx 1 plus 1 over 2t. And here we again pass to derivatives for t, writing it this way. d 1 plus 1 over 2t dt, divide by dt top and bottom, dx over dt. And we can do this. Let's find these derivatives. d 1 plus 1 over 2t dt, that's derivative for t, derivative 1 is 0, derivative 1 over 2t will be negative 1 over 2t squared. Because if you differentiate 1 over 2, you get negative 1 over t squared. Also, the x dt we already know. The x dt, this is 2t. So our second derivative becomes negative 1 over 2t squared divided by 2t. So this will be negative 1 over 4t cubed. In terms of t, this is our second derivative. And we want this to be positive. We have to solve this for t, find equality for t. If we multiply by negative 1 both sides, we have 1 over 4t cubed. Should be positive. Sorry. So we have to switch the inequality. So this should be negative. And this corresponds to t negative. Because numerator is 1, always positive, the denominator determines the sign. When t cubed is negative, t is negative, and when t is negative, t cubed is negative. So this is how we answer this question. What other things we can do? Here is a problem, again, of different nature. Given is the curve with equations x equals t cubed minus 3t, y equals t cubed minus 3t squared. And now the question is this. Find points on the curve where the tangent line is horizontal. Or vertical. So we have to find all points on this curve, which is defined everywhere, where we have horizontal tangent line or vertical tangent line. Now, horizontal tangent line corresponds to slope 0. Let's write this here. Horizontal tangent. This means slope is 0. Vertical tangent. Slope is infinity. That's not a number, but this means when we approach this point, the slope approaches infinity. And now remember how we find the slope. The slope, this is y prime t over x prime t. Here, for our curve, y prime will be 3t squared minus 6t, and x prime is 3t squared minus 3. Look, we can reduce by 3. I can divide top and bottom by 3. This will be written t squared minus 2t, and below we have t squared minus 1. Now this will be 0 when y prime is 0. Slope is 0 when y prime t is 0. Y prime here, yeah, I changed it, but this is, I shall write same as t squared minus 2t equals 0. And we can solve this for t. When we factor, we have t times t minus 2 equals 0. We have two values. T1 equals 0 and t2 equals 2. For these two values of t, y prime is 0. The denominator is not 0, so we have 0 here for the slope. And let's find these 2 points for the curve. X of 0 equals 0, y 0 equals 0. So 0, 0 is one point with the horizontal tangent. Then x of 2, from the equation for x, this will be 8 minus 6 will be 2. Y of 2 will be 8 minus 12 will be negative 4. So another point is 2, negative 4. So at 0, 0 and 2, negative 4, we have horizontal tangent. The first half of the problem is solved. Now about vertical tangent. For vertical tangent, and again I'm writing the slope, y prime t, x prime t. Slope will be infinity when the denominator is 0. And let's see what was this. So this corresponds to t squared minus 1 equals 0. This factors t minus 1 times t plus 1 equals 0. So we have two values here. Let's call them t3 equals 1, t4 equals negative 1. Negative 1. For these values of the parameter, x prime is 0 and we have slope infinity. Let's find the points. X of 1 will be 1 minus 3 will be negative 2. Y of 1, this will be 1 minus 3, again negative 2. So we have a point negative 2, negative 2. For negative 1, x negative 1 will be negative 1 plus 3 will be 2. Y of negative 1 will be negative 1 minus 3 will be negative 4. So here we have a point 2, negative 4. So we have vertical tangent at negative 2, negative 2, and 2, negative 4. And now a natural question appears. What happens at this point 2, negative 4? We have at the same time vertical and horizontal tangent. How is that possible? Here we found this same point for horizontal tangent. How is that possible? It's quite possible. The curve intersects itself. This point on the curve corresponds to two different values of t. If you graph the curve on your graphing calculator, you'll see what happens. First it goes horizontally through this point, then it goes vertically through this point. I shall just sketch how this could happen. Let's see, this is such a point. So the curve goes like that. You have Let's make a better horizontal tangent. So I shall do it this way. Short horizontal line and short vertical line. So see how this could happen. The curve goes here, touches horizontal tangent, then makes such a loop and has a vertical tangent also. This is quite possible. It's one and the same point on the curve, but correspond to different values of the parameter. So when you are tracing the curve, you're going twice through the same position. Okay, now it is good to do problems like this, and then when you find tangent lines or other things, check this on your graphing calculator. Construct graph the tangent line and the parametric curve on the same screen to see how they touch. Do they touch? If you have a mistake, you will not get the right tangent line. This way you can check your mistakes. Goodbye for now.